All right, welcome back, guys. I hope everybody's doing well. Doing well throughout the fourth quarter, and we are moving right along and only down to a few more weeks left. What we're going to do today, kind of a complete shift of gears topics-wise from everything we've done with systems of equations, and we're sad to see those go, but we are going to move into what I would consider as my favorite section. It's all in the name, really. It's simplest radical form, and if that doesn't get you excited, I really don't know what will. But anyway, here's the question. Well, kind of the review question to think about here at the beginning. So again, totally new topic, but fun nonetheless, of course. So the review here is radical, meaning square root. So what does a square root operation do? Okay, and the answer to that question is it tells us which number squared produces an original number that was inside. Okay, so now I can't spell, but we'll pretend that that says produces. All right, better. So, a question that I'm sure you all know the answer to right now. The square root of 4 is equal to 2. Right? Not shattering the earth with that one. You knew that. And again, the reason why is of what a square root definition is. The number 2 squared multiplied by itself, meaning gets me back to 4. The other thing before I flip this board here for the examples, make sure you have this list of numbers jotted down. This is the list of all the perfect squares 1 through 100. Okay, and you're going to see why this list of numbers is very important throughout our section as we do this. So the easy questions all come from this list, right? Square root of 4, it's a perfect square. Gives me a whole number square root, the definition of a perfect square or integer square root, right? So if I give you the square root of 49, the answer very simply is equal to 7, because 7 squared would get me back to 49. However, what we're getting into is what happens when things aren't so pretty, I suppose. What happens when we're given a number that is not a perfect square? So again, if you didn't, rewind back to that last list, make sure you have those written down in front of you. Okay, 24 is not in the perfect square list. 25 is. Its square root is 5. So if I were to type this number into a calculator, the square root of 24, I would get some messy non-ending decimal or non-terminating decimal that's a little bit less than 5, right? Maybe it's about 4.8, 4.9, somewhere in there. Okay, so I'm not asking for decimal approximations. We want exact answers. Okay, so there are a couple ways that these can be done. And actually, don't write this down, but the whole basis of simplest radical form. Let's say I told you, and this is unrelated, that the answer to a question is 4 over 8. Hopefully there's an OCD bell and whistle going off in your head that says that is not how I would leave a final answer. I would reduce this to 1/2. Right? 4 over 8 reduces to 1/2. That is what we are doing with these radical expressions. I am breaking them down in as simplified terms as they can go. And the first question we ask ourselves through this process is, are there any perfect square factors? Perfect square factors, so numbers that multiply. Perfect square factors of 24, the number that's inside. The answer to that question is yes, there is. Think about your factors of 24. 1 and 24. All right, it's never going to help to start with 1 in itself. Next, 2 and 12. Nope, 2 and 12 are not perfect squares, so I'm not there yet. Let's try 3 and 8. Nope. 3 and 8 also doesn't work. 3 and 8, neither 3 nor 8 are in that list of numbers I wrote down. However, its last pair, think of 4 and 6. That is the pair I want to start with, and here's why. 4 times 6, the number 4, is a perfect square. So here's how I start the process with these problems. My whole idea is I want to break this problem down into at least one number where I can take its whole number square root. So what I do is I kind of branch off. It'll almost look like kind of a factor tree at the beginning. My favorite kind of tree anyway. Okay, and here's what I do. I always personally, for my OCD purposes, write the perfect square first times the other number that was paired with it. Okay, So the square root of 4, this is why I chose this number. Its square root is a whole number. It's 2 times the square root of 6. This is a number that is not a perfect square. That's it. That's all I have to do. The only thing I would want to do is check to make sure this number is not also a perfect square or have a perfect square factor in it. The only factors that 6 has, other than itself and 1, is 2 and 3. Neither 2 nor 3 is a perfect square. That is how I know I'm finished. So the answer is red, 2 radical 6, or 2 times the square root of 6. And that's our final answer. So again, reducing a number inside a square root by breaking it down into numbers that are perfect square factors of it. Okay, so hopefully you followed that. We're going to do a second one here, number 2. Now, square root of 72. So once again, I think, are there any numbers that are perfect square factors of 72? There are actually a few of them. My guess is if you thought of factors of 72, most likely people think of 8 and 9 first. The nice thing with this process is I can start anywhere. There are other numbers. See if you can think of them. So let's say I break 72 down into the square root of 9 times the square root of 8. Okay. Going along with our procedure from the last question, what I do is the number that I chose that was a perfect square, I take its square root very simply. The square root of 9 is 3. Okay. This is where we have to be careful. I can't assume I am done here, and I'm actually not. Because if I think now about factors of 8, I actually have one that is a perfect square factor. The answer is 4, because 2 times 4 gives me 8. So what I have to do is continue breaking this number down. Keep the 3 on the outside for now. I want to break 8 into the square root of 4 times the square root of 2. The square root of 4, once again, just keep this here for now. The square root of 4 comes outside as 2. So 3 times 2, radical 2. Final step, I can multiply any numbers that are outside of the radicals. 3 times 2 is 6. So the answer here, 6 radical 2. So once again, you always just have to make sure that once you've broken it down one time, that the number left over does not go any farther there. Okay, and the other thing with these problems, the one that involve multiple steps like this, make sure you keep all your work organized. So you can see that I carried everything down line by line as I wrote it. Okay, so 6 radical 2, final answer there. The last thing here we're going to finish up with are 2 quick ones. Okay, number 3, what is the square root of 64? Be so surprised how many times once I've done example numbers 1 and 2 that people get this one wrong. Alright, so now think, okay, are there perfect square factors of 64? Hopefully you realized I gave you an easy one. 64 is in the perfect square list itself. It is a perfect square. The square root of 64 is 8. That's it. Anytime it's a perfect square, I better not have a square root in my final answer. Finally, number 4. So again, moral of the story, always make sure to check that it isn't an easy one. Square root of 19. Okay, hopefully you're sitting there raising an eyebrow. Are there any perfect square factors? There are not. The answer to this is that's a prime number, so this expression is already simplified. All right, so there we go. There's an introduction to simplest radical form. As always, check your email. See me in office hours if you have any questions. Be happy to help out. I hope you have a great day and have a great week.